So hi, I'm Allison from the University of Wisconsin-Madison, and today I'll be presenting work done jointly with my advisor, Bilge Mutlu, on the social impact of a robot factory coworker. So robotic technology has been employed in manufacturing plants for decades, and many industries, such as the automotive and aviation industries, have used robots on their production lines to both increase the efficiency of their production, helping to cut costs and increase revenue. However, this efficiency relies on robots having dedicated work environments, as we'll see in the next video. So here we have a video of a car manufacturing plant, and the robots in the center are large pieces of industrial equipment performing dangerous welding operations. And for the workers' safety, these robots are caged off to prevent the human workers from being placed in harm's way. And so you'll notice, as a result of this physical separation, the human workers are actually forced to the periphery of the plant while the industrial robots are placed in the center. So robots like the ones shown in the previous video are viewed as a type of factory automation. And these robots are unaware of their environment and thus dangerous to the human workers that they're near. As a result, if a human would like to enter the robot's workspace, the robot must first stop working, and then the human worker can enter the workspace. So recently, a new class of robots have come out called collaborative manufacturing robots. And these are really poised to revolutionize the way that people work in manufacturing plants. These robots fill a radically different role than the traditional industrial robots we saw previously. And due to advancements in robotics, these robots are actually safe enough for humans to not only work near, but together with, allowing the robots to provide a complementary skill set to working with human workers. These robots can perform more repetitive, physically challenging, or precise tasks, while humans can perform tasks that require more adaptivity or dexterity. These advancements create a new interaction paradigm, where a human and robot can now share a space as coworkers. The following clip from Iron Man shows an idealized version of what this interaction might look like in the future. So here we see Tony Stark working with a robotic arm, and he's verbally directing it to where it should position itself so that he can use the magnifying glass that the robotic arm is holding. And this provides a very fluid interaction between Tony Stark and the arm for completing the work together. So the introduction of these collaborative manufacturing robots raises the question, how will the robot's role as a coworker shape human workers' interactions and perceptions of the robot? And when looking at this question, we actually considered it from two different viewpoints. First, how do people perceive and interact with a robot that they share a workspace with? And then second, how do the design considerations for these systems differ from other types of industrial robots, like the ones we saw at the beginning of the talk? So to answer these questions, we conducted an ethnographic fieldwork at a number of sites. And it turns out that the introduction of these collaborative robots, with the introduction of these factory robots, factory workers actually extend their social ecosystem to encompass the robot, such as one field site, which chose to add a wig and jester hat to its robot because they thought it fit the robot's personality. Additionally, designing these robots requires accounting for social perceptions, a consideration previously not needed for industrial robots. So today, I'll be describing the fieldwork conducted for this study, as well as the findings and implications from this work. I'll start by discussing the study design, followed by the data collection and analysis. I'll then present the findings and discuss their implications. So I'll start by reviewing our study design. For this work, we focused on a collaborative manufacturing robotic platform called Baxter that was released by Rethink Robotics in 2012. Baxter is one of the more widely adopted collaborative robot platforms and is optimized for a particular kind of task called a pick-and-place task, where the robot picks up an object and relocates it to a new position, as we'll see in the following clip. So here we see Baxter first picking up a stack of medicine cups and then relocating them to a loader for an automatic bagging machine. Baxter then triggers the machine to bag the cups, and the completed bag is deposited in a bin for human workers to later come by, retrieve, and pack. I visited 3 different manufacturing sites located in the continental US for this study, all of which had acquired a single Baxter platform in the 4 to 8 months prior to my visit. These sites varied in size, with 2 sites having fewer than 60 employees and 1 having close to 200 employees. As part of my visits, I focused on 3 different classes of stakeholders: management workers, who were responsible for deciding to purchase a Baxter; maintenance workers, who were in charge of integrating and major troubleshooting problems for Baxter; and operators, who were often responsible for working near Baxter, as well as handling minor day-to-day troubleshooting issues. So next I'll talk about our data collection and analysis process. As part of the data collection for this study, I conducted fly-on-the-wall observations at all 3 sites, and these involved both watching the robot as it went about its work, as well as the human operators that were working by the robot, regardless of whether or not they were interacting with the robot. I also conducted semi-structured interviews with all 3 classes of stakeholders that I mentioned previously. We used a grounded theory approach to analyze both the observational data as well as the interview data, which involved an iterative open coding process of data for significant events, and then axial coding to identify phenomena from among the open codes. So some example of the resulting codes were things like personality, viewing Baxter as an intentional agent, and viewing the robot as part of a larger system. So now I'll touch on some of our findings. I'll be grouping our findings today under 2 main themes that relate to the research questions from before. The first is the social perception of and interaction with the robot that stakeholders encountered, and then the second is designing social behavior for efficient collaboration. These are only a subset of our findings, and I really encourage you to read the paper to learn more about our results. So first I'll be talking about the social perceptions of and interactions with the robot. Manufacturing plants are often characterized by their dedication to efficiency, minimizing considerations for sociality. However, it turns out that plants are incredibly social environments where operators frequently communicate amongst themselves, both for work as well as social purposes. So interactions with the robot are patterned on interactions with other coworkers. For example, one operator from Company 3 said, "I need somebody to talk to. I couldn't teach him, the robot, to talk. I tried to teach him to deal cards, but that didn't work either." As a result of this, we noted that the operator-robot relationship was a special kind of relationship amongst the stakeholders. Operators tended to use more collegial or familial terms when describing the robot. So they might say the robot is a work partner, a friend, a coworker, or even a son. And operators would discuss the robot with acquaintances outside of work, with sometimes their friends asking how the robot was doing. One particular operator said that the robot just has a hard time doing work a lot, especially when he goes down. I'm like, "What's up? It feels like babysitting my grandkids." So this particular operator was noting a more negative relationship with the robot, but was relating it back to these familial connections that the operator had. On the flip side, maintenance and management staff had a very different type of relationship with the robot. These types of stakeholders tended to use more mechanical terms to describe the robot. So they might refer to the robot as error-prone or monotonous. So one maintenance worker said, "Our biggest thing is to tie Baxter into the bagger, tie Baxter into the conveyor, and tie Baxter there. And again, it comes down to inputs, outputs, and there's not a lot of versatility. Right now, I have to sit here and meticulously program every little speck of dust where vision would be." So this maintenance worker was expressing some frustration, but also a very mechanical view of the robot as just one more piece of equipment in the factory that they needed to program, maintain, and get working up to code for efficiency purposes. And this supports prior work, which has found that different stakeholders will perceive the robot in different ways. So here we see the operators having a much more collegial relationship with the robot, while maintenance and management workers have this much more mechanical view of the robot. Another finding that relates to social perceptions of the robot is this attribution of human-like characteristics. So as I mentioned before, operators at the Site 2 had actually added a wig and a jester hat to Baxter, and they felt that it fit its personality. So one operator said, "To me, it totally fits him. So if he's in a good mood, it fits him, or sometimes he just has an attitude. Whatever, you know? That look is just him." And we noticed this at many different sites, where operators would refer to the robot as having some sort of personality or attributing intent to its actions, maybe braking on purpose, for example. And this supports prior work, which has found humans to attribute human-like characteristics to computers as well as more domestic robots like the Roomba. So next I'll be touching on some of our findings in relation to our second research question. And these have to deal with designing social behaviors for efficient communication to work between the robot and the operators. So one of our first findings has to deal with this idea of design eliciting familiarity, and particularly the human-like design of Baxter, where it has a torso, 2 arms, and some semblance of a face with the screen. It not only elicits this familiarity, but as a result elicits security from workers. They're more willing to work around it because it's familiar to them. As one maintenance worker said, "I like that it looks kind of like a human. It's familiar, you know? I feel like I know what to expect." Another result from this is the idea of using the eyes on the robot for communication. Several of our informants noted that the eyes naturally help to communicate intent and intelligence without any sort of additional training. One management worker said that they, the new employees, don't usually understand what the robot will do next, where it will go. The eyes, this helps them get it. So the addition of the eyes, which act in a human-like way by following the actual motion of the robot, indicating where the robot's arm will go next, help the workers to understand what the robot is going to do next to help them work around it. Finally, we saw that many different stakeholders viewed the robot as a social entity. And so one operator noted, "Now I don't like to look, I mostly listen. He's like a child. If he's been quiet for too long, I know something's wrong. We've developed an understanding." And many different stakeholders noted that they had this idea of communication with the robot, primarily through listening, but some people also wish that the robot would be able to talk so that they could interact with it as a social entity. So next I'll be talking about some of the discussion points resulting from this, as well as the implications of our results. So the first has to do with designing for sociality. So despite the focus on efficiency, sociality was cited as an area for improvement at these manufacturing facilities, which really surprised us. And it turns out that it stems from the role of social interaction that's already present in these environments. So for example, 2 workers who may be working near one another might use gaze to understand their coworkers' intentions or next movements. Another example is that 2 workers who are stationed close by to one another working on a task might actually have informal conversations with one another to help pass the time socially. Additionally, the appearance of the robot and possibly its role as an equal to working next to these human workers elicits a sociality that previous industrial robots didn't. So we never observed or had informants tell us that they might talk to a conveyor belt or a more industrial welding robot like we saw in the first video. So this is really eliciting a new type of interaction that we hadn't seen with previous manufacturing robots. But we should caution that developing the sociality of these types of robots has the potential to actually create false expectations for workers' safety. If workers start to feel increasingly more comfortable around the robot, they may feel that it's becoming too safe and might not remember that the robot can still be a dangerous piece of equipment from time to time. Additionally, I noted some of the new possibilities for design earlier when talking about the results, and this raises new design questions. The focus on social behaviors and their role in supporting work needs to be developed. So, for example, gaze to understand robot movements is already starting to be there and could be further developed. But also the physical appearance to build trust was noted as a surprising result that might be useful to implement in future collaborative manufacturing robots. And so this really raises the question of how can we develop behaviors for a robot code worker to aid in task efficiency? And task efficiency might actually be broken down into some surprising areas, like how do we build this trust between a robot coworker and a human worker? And physical appearance might be one of those areas. So to conclude, I talked a little bit today about collaborative manufacturing robots and how they allow humans and robots to share a common workspace. And this raises new questions about perceptions and interactions of the robot from their human coworkers. I presented some fieldwork examining these worker perceptions that had two main results. The first was the social perceptions of and interactions with the robot, and the second was these new design questions concerning designing social behaviors for efficient collaboration. And future work should focus on developing the sociality of these robots to aid perceptions and collaboration. And with that, I'd be happy to take any questions.
We have plenty of time for questions. Please use the microphone in the middle of the room. And let me start. I have a question. I was wondering if you observed anything about how people relate to traditional robots after the Baxter had been introduced. I was wondering if you noticed if people changed their relationship to those as well.
Sure. So the question was, did I observe in these field studies if workers had changed the way that they interacted with more traditional robots after the Baxter had been introduced? So I can only speculate a little bit since I didn't visit these sites prior to the robot being introduced. But based on what I observed of workers who worked near the robot as well as workers who did not work near the robot, nothing seemed to change. They still treated these as highly industrial machines that were unsafe. They didn't try to talk to them, change anything about their behavior, and so on.
Hi, I think this work is really intriguing. Actually, I have a quick question about if you have any plan to implement some cultural gestures in your future research, because actually I studied social interaction in University of Illinois, Urbana-Champaign, and I found some specific gestures actually affect people's social evaluation. For example, actually Western male was more sensitive to handshaking behavior, so that was my master's topic. So yeah, I really like these studies, and yeah, I would like to know if you have any thoughts about how to implement some specific cultural gestures to your future study.
Sure. So the question was about culture and how this generalizes to that. So all of the operators and actually all the stakeholders that I interacted with were American citizens born and raised in the U.S. So I didn't notice anything there that would indicate possible changes. But I think one thing that this study shows is that the way people currently interact in their manufacturing environments, they tend to extend that environment socially to the robot. So for example, if two coworkers are working together and they tend to talk to each other, they now want to talk to the robot when the robot is introduced. So I think a good way to approach that in other cultures where that might be different is to look at how are humans currently interacting in a manufacturing environment in some other culture? What does the social ecosystem look like there? And then how would that possibly extend to the introduction of a robot? So maybe talking to your coworker is not common or is not acceptable. So then maybe that's something you don't want to do in that situation.